We have discussed electrochemical cells, batteries. Electrochemical cells, we have discussed what are galvanic cells and electrolytic cells. So galvanic cells are discussed what is Daniell cell. In galvanic cell, what happens? The chemical energy is converted into electrical energy, right? So by virtue of electrical energy, some chemical changes are brought about and they are called as electrolytic cells. So galvanic cells, when two or more galvanic cells are combined either in series or parallel, it acts as a battery. So battery, we have primary battery, secondary battery and reserve battery. We have seen the classification of batteries also. So now let us, and we have also seen the construction and working of two secondary batteries. Lithium ion battery, nickel metal hydride battery. Now, today's discussion, there are separate types of galvanic cell. They are called as concentration cells. What are concentration cells? So, concentration cells are also a type of galvanic cells. Let us see what are concentration cells, how will they work in today's discussion. So, concentration cells. Concentration cells are electrochemical cells or devices where both anode and cathode are made up of same metal and are in contact with electrolyte solution of different concentration. So in our galvanic cell, we have anode and cathode made up of different metal and they are in contact with their own salt solution. But here, the concentration cells, both anode and cathode are made up of same metal and are in contact with their own salt solution but of different concentration. Then how? Since they are in contact with same, you know that only if the concentration is different and only then the potential electrons will flow from one metal to the other. Since the concentration is same, it will not flow, right? Then what is how a cell is formed? So due to difference in concentration, the electrons will flow from lower concentration electrolyte to the higher concentration electrolyte. Even though the both metals are same, anode is cathode is same, they will be dipped in the electrolyte concentration, electrolyte of different concentrations. So since the concentrations are different, since the concentration of electrolyte is different, we can observe the flow of electrons from lower concentration electrolyte to the higher concentration electrolyte. So the lower concentration flow can be observed until the concentrations of both electrolytes are equal. Once the concentrations of the both electrolytes are equal, we can no more observe the flow of electrons. Now let us take an example of zinc concentration cell and discuss what is anodic reaction, cathodic reaction and electropotential, how to determine one by one. Let us see the difference between galvanic cell and concentration cell. So in galvanic cell, the type of electrochemical cell which uses redox reactions to produce the energy. In concentration cells, so what happens, both the half cells are made up of same metal but dipped in same electrolyte of different concentration. So the concentration difference is the driving force for generating the current. The electrodes in the galvanic cells are made up of different metals, whereas in concentration cells they are made up of same metal. Both anode and cathode will be made up of same metal and same substance. The electrolyte is in the galvanic cell are the salt solution of the metal, right? And there will be different, since zinc is dipped in zinc sulfate, copper and will be dipped in copper sulfate. Even though they are of same concentration, they are of different metal, does not matter. But here the anodic electrolyte concentration, cathodic electrolyte concentration are different. Here both anode and cathode are made up of same metal and dipped in same electrolyte solution or salt solution but of different concentration. That is regarding to electrolyte. So when you come to, let us consider the example of zinc concentration cell. Our zinc concentration cell, if we take, so both anode and cathode are made up of same metal. So zinc concentration cell, we have anode is zinc and cathode made up of same metal. So zinc is dipped in zinc sulfate solution of 0.1 molar and here zinc is dipped in zinc sulfate solution of 1.0 molar. As definition says, the electrode where metal is dipped in lower concentration electrolyte, the electrons will flow from lower concentration electrolyte to the higher concentration electrolyte. So as for IUPAC, the electrode which is dipped in lower concentration electrolyte will act as anode, and the electrode is dipped in higher concentration electrolyte will act as cathode. So zinc dipped in lower concentration electrolyte will act as anode. This is 0.10 will act as anode. Zinc dipped in 1.0 molar zinc sulfate solution will act as cathode. So these both will be connected through the salt bridge and to the voltmeter. Right. So zinc dipped in zinc sulfate solution, zinc dipped in zinc sulfate solution of different concentration. This is of 0.10, this is of 1.0 molar. So lower concentration electrolyte will act as anode, higher concentration electrolyte will act as cathode. Right. So due to difference in concentration, electrons flow from lower concentration electrolyte to the higher concentration electrolyte. So until when? Until the concentration of these both are equal. So once the concentration of these both are equal, you can no more find the flow of electrons. Right. So the main motive is difference in concentration of zinc. So next, so what are the reactions occurring at anode? At anode, zinc undergoes oxidation to give Zn2 plus and 2 electrons. Since cathode is also zinc, this Zn2 plus ions present at the cathode will accept the 2 electrons donated by the anode and gets reduced. Since both anode and cathode are made up of same metal, the overall reaction is 0. Why? Because Zn present here will get cancelled with this. The Zn2 plus present here will get cancelled with this. 2 electrons will get cancelled. Therefore, overall reaction will be 0. So we can find the flow of electrons until the concentration C1 is equal to C2. Once the C1 is equal to C2, EMF will be equal to 0. Let us see how to determine the electrode potential of an concentration cell. The electrode potential of concentration cell is given by the Nernst equation. E cell equals 0.0591 by N log concentration of C2 by concentration of C1. So here N is number of electrons lost during oxidation or reduction, right? As C2 is cathodic species electrolyte concentration by C1 is anodic species, that is electrolyte which acts as anode, that is C2, and electrolyte which acts as cathode is C2, electrolyte which acts as anode is C1, that is cathodic electrolyte concentration divided by anodic electrolyte. So here where C2 is greater than C1. So C2 is greater than C1 means, as we have discussed earlier, the electrolyte which is lower in concentration will act as anode, higher in concentration will act as cathode, right? So we can see or observe the flow of electrons until C2 is greater than C1. Once C2 is equal to C1, we can no more observe the flow of electrons from anode to cathode. This is regarding our concentration cells. So we'll discuss the flow of some problems in our next discussion. Okay, thank you.